-3. So we're plugging this piece in, and we're going to figure out where this particular one stops. And so this one stops at the y equals 3. Y equals 3. And we're going to do the same thing for the second piece, because we've got to figure out, do they stop and start at the same point? That would mean they're continuous. Or does one of them stop here and then jump and go to a different point? So then we're going to plug this into the second one. Negative x, so negative 3 there, minus 2. What does that give us? 3 minus 2 gives us 1. Those are two different y values. What does that tell me? Well, that tells me that it is discontinuous, right? We have a jump. If I were to graph this at -3 over here, I have some function that is a parabola of sorts, right? That is going to, at +3, do something like that. But then over here, when I get to the next function, it's going to drop down here and be this linear function of sorts, okay? And so that's going to tell me it's discontinuous. So I do know it's discontinuous. Find the x-axis location of that discontinuity and classify it. So you're going to say jump. It's a jump discontinuity at x equals -3, right there at that point where we had a problem. All right, something like this, when you have a rational, you are looking to see if you have a problem where? In the denominator. Specifically, we cannot have a 0. So I am looking for any problems in the denominator. What I'm going to do, though, is I'm going to factor all of it. So I do have a negative in front, so don't forget there's a negative there. Sometimes that matters when you plug stuff back in. The x plus 5 on top is as simple as it can be. And then I'm going to factor the bottom. How do I factor x squared plus 6x plus 5? What are my two numbers that add up to 6 that multiply to give me 5? Yep. So I'm going to have two problems in the denominator, right? Two types of discontinuities. What two numbers will cause a problem in the denominator? What's going to cause a problem here? -1 there, yep. And here's -5. Now here's the thing, I have two types of problems. One of them I can get rid of. Which one can I get rid of by canceling? Yeah, so this one I could actually do that. That is called a removable. And that's what we're actually going to put there. We're going to say that is removable. It is also called a hole. You have a hole in your graph. I will take either one of those explanations, removable or hole. Those mean the same thing. It means a removable discontinuity. In the graph, it actually creates a hole. So either one of those is fine. If I cannot take it out, I cannot cancel it, then that is what we remember, if you recall, we called that an infinite. An infinite. And the reason is it goes off to infinity when you have those. And when we start sketching those graphs, you'll see that. The first type here is a piecewise function, just like we did with our discontinuities. And you're going to break this graph into pieces, okay? You're going to look at your domain, and you're going to decide how this domain has split up this graph for you. The first thing you'll notice is a domain of x is less than or equal to 4. And so I'm going to go to 4 on my graph, and I'm actually going to just put a highlight or a dashed line or something, so visually I know that's where this particular one ends. It's also less than or equal to 4, so that indicates that I'm going to have a closed circle when I do graph this piece of it. Okay? Then I'm going to look at what type of function I have, x minus 1. If you look at the parent function thing that I just gave you, to the first degree is just a line. Hopefully you recognize x minus 1 is y equals mx plus b, right? I have a y-intercept of -1 and a positive slope. And so you can graph it like that. If you don't remember that, you can just pick some x's and plug them in. Pick an x, always pick your 4. So 4 minus 1, if I plug in a 4 for this guy, I'm going to get a y value of 3. So I know that this graph is going to end right there, right? I also know that I have a positive slope. So going to the left of this, I'm actually going to go down so that the line goes up. But you can pick one more point. Let's say 0. If you plug in a 0, you get your y-intercept of -1. And so you can say, 0, -1 is also on this piece of my graph. And then you can just connect your dots, right? You can just connect those and draw your line, a linear graph there. That's the first piece. Then I'm going to look at the second piece. The second piece, if you look at your parent function, if it's squared, it's a parabola. We know this is going to create a parabola. I could even figure out where the vertex of this parabola is, right? On the inside, it moved it left and right, and specifically it moved it right. So my vertex actually would be sitting down here somewhere, right? But I know that if I were to plug in a 4, I would get 0. So if I choose that y value, choose that endpoint, and get 0, that's what's going to happen. However, it is just greater than. So this point right here should be an open circle. So I am going to want to graph that endpoint. I'm going to plug it in and see where it actually falls on my graph. But I do know that this is an open circle. It is not closed. And I dotted it so it looked closed. So I do want to put an open circle here. And this is a parabola, so you can choose another point to the right of that, right? Because it does say everything bigger than 4. So I could say something like, well, let's do 6. If I plug in a 6, 6 minus 4 is 2. 2 squared is 4. So by the time I get to 6 on the x-axis, I will be there. And I know from my parent functions that that's a parabola. And so that is my function. I have a line when I am below 4, and I have a parabola when I am greater than 4. You've put pieces of functions together. It's called a piecewise function. So when you have these next sets where it's asking you to graph, you'll be given a graph and you need to recognize the parent function. You don't have to graph the parent function, but if it helps you, you can, right? If you need to sketch the parent function, just make sure I know what your final answer is if you sketch anything on it, all right? So you're going to look at this and you're going to say, okay, I have squared. This is squared. That tells me my parent function is y equals x squared, which we know is a parabola, right? Which we're going to do a lot of. And then you have to decide, is it being flipped or stretched? Is it being moved left or right? What's happening to this particular function? And so my parent function, if I were to sketch it, right, he's going to be right here, right? And I'm just dashing it because he's not part of my function. So the first thing I typically look at, is it going to be flipped or stretched? And I do that by looking at this right here. Remember, if you have a negative in front of that, he's going to flip over the x-axis. And so if he flips over the x-axis like that, he would shift down here and just point down. Now this particular one has a 1, so he actually doesn't stretch at all, right? He just flips. And then the next thing I'm going to look at is, does it move left and right? Remember, this tells you left and right, and anything out here would tell you up and down. Okay? So inside's going to tell you left and right, outside's going to tell you up and down. Remember, inside goes opposite. So if it says -3, I'm actually going to go to the right 3. And I don't go up and down at all for this particular one. So I'm just going to take that graph that I just had, and I'm just going to move it to the right. So when you see the word identify the parent function, you need to actually list it out for me. The parent function is f of x equals 1 over x. So hopefully when you see that little mark, you know that's 1 over x. Now, if you look at your parent function, what do you notice about it? Well, your parent function looks a little bit different, doesn't it? What's different about your parent function? It should be something like this on your sheet, right? That's beautiful, but you get the picture, okay? Right? Looks something like that. So it flips. So what does that tell me I'm going to have in front of my parent function? I'm going to have a negative. So immediately I should recognize that I'm going to have a negative in front of my function, right? And then you should also notice that it's not at 0, 0. So this little guy where these two little dashes cross is normally right here on my parent function. So he moved either left or right or up or down, didn't he? How did he move? He moved down. How many spots? 3, right? Is that on the inside? So is that going to be here inside with my x, or is up and down going to be on the outside? On the outside. And so now I know to say minus 3. And so this is my moved function right here. You've answered both questions, parent function and this new function. You've given me the actual definition of that new function. Quiz, I'm actually going to have the instructions listed differently, so you may want to write this down so you remember that you have to give me all this information. You'll be able to glean the information when you see the graph on your answer key, but I'm actually going to ask you to list the axis of symmetry. I'm going to ask for the vertex, and I'm also going to ask for the y-intercept. All right? So I'm going to ask for all 3 of those as well as the sketching of the graph, okay? And I need to see all of those on the graph if they're on the graph. So this particular one, the y-intercept falls off this graph. I usually try to make sure on your quizzes that the y-intercept is on the graph. Remember, there's 2 different forms. So the first one is vertex form. So the first one that I have here is vertex form. In vertex form, so for vertex form, it's going to be listed f of x equals a x minus h squared plus k. That's my vertex form. For standard form, remember standard is just ax squared plus bx plus c. All right? So there's different way to find these particular things depending on what form you have. For vertex form, the axis of symmetry is just x equals h. X equals h. For standard form, the axis of symmetry is x equals negative b over 2a. For vertex form, the vertex is just hk. For standard form, remember you have to take that x value that you just found, negative b over 2a, and that is your x. And then you plug it in. F of, that just means plug it in. F of negative b over 2a gives you your y value. So your axis is your x value. Plug it in to get your y value. And then for vertex form, your y-intercept, you're going to have to plug in a 0 and solve. So you have 0 always as your x, and then plug in the 0 to figure out your y. And then for standard form, that's the one they kind of give you. It's just 0 and c. So those are the two forms that you're going to have, and the 3 things that you need to give me each time. So let's look at these 2 examples. The first one, negative times the quantity x plus 3 squared minus 3. All right? So I'm going to find my axis. My axis is just h. Remember, h is the opposite of what you see on the inside. That says plus 3. So your axis is going to be at x equals negative 3. So I'm going to actually sketch that axis. This particular guy is dashed. He's not part of the actual function. He's just helping me sketch it. Okay? He's helping me sketch. Then I'm going to do my vertex. My vertex is just hk. H is opposite, so that's negative 3. It should always match my axis that I just found. And k is exactly what you see, negative 3. So I'm going to go to the point negative 3, and sketch there. Now I'm going to find my y-intercept, but in this case, my y-intercept is going to fall off the graph. So if I look here, y-intercept, I have to actually calculate this. I know my x value is 0, but I have to plug it in. So I have to say negative 0 plus 3, quantity squared, minus 3. 0 plus 3 is negative 3, or 3 squared, negative 3, negative 9 rather, minus 3. So I'm going to say negative 9 minus 3, negative 12. So negative 12 falls off this graph, but I'm still going to actually list it. Now, normally I would use my y-intercept to mirror it to help me figure out, but I can also figure out which way it's going another way. My A is negative, right? This is negative. So that tells me this is going to point up or point down. Up or down. Yeah, this is going to point down, right? Because that A is negative. And so I can just sketch it like that since I don't have that y-intercept to sketch. For standard form, we do have to calculate more than we did in vertex form. So for axis of symmetry, we have to actually solve. Not that it's difficult, but we do have to solve for that axis. Remember, it's negative b over 2a. In this case, b is negative 4. So I'm just going to make it the opposite. That's going to be positive 4 over 2 times, and my a was 1. So 4 over 2 is just 2, so my axis is x equals 2. And so I am going to do a dashed line right there at 2. Then I'm going to do my vertex. My vertex, again, I have to do some calculation for this. I know that the x value of my vertex is going to match that axis that I just did, but then I need to plug it into the function x squared, so that's 2 squared, minus 4x, so 4 times 2 plus 6. So I have 4 minus 8 plus 6, so I'm going to get 2 there. So that is the y value of my vertex, which is 2. So I'm going to go to the point 2, 2 and plot that point. Now for standard form, my y-intercept is kind of handed to me. It's just 0 and c. In this case, c is 6. To the 0, 6 and plot that. And now in this case, you can actually mirror that point. So if I have a point here at the 0, 6, it is 2 away from my line of symmetry. I can go 2 away on the other side, and I know there's a point that will mirror over here. And then I can sketch this graph a little more accurately when I have that y-intercept. There are 2 ways to figure out your zeros. Remember, your zeros just mean your x-intercept, okay? That's all it means. So all it means is set this thing equal to 0 and solve. There are 2 basic methods that we typically use. There are other methods, but the 2 that we use the most, if you set it equal to 0, you can solve by factoring or by the quadratic formula. All right, if you don't know the quadratic formula, you probably want to make sure you know it. All right, the ones up here, this is factorable. So anytime the last guy can be split into factors that add up to the middle, that's the method I'm going to use. And so this is factorable. So if I set this equal to 0, which is my first step, set it equal to 0. I'm going to say what factors of 6 add up to 5? Well, that's 2 and 3. And then I have to set each of those factors equal to 0 to figure out what those are. So my zeros are going to happen at -2 and -3. Those are my zeros. All right. If I could not factor it, I would plug it into the quadratic formula. I would say -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. This is going to be 25 minus 24, so that's the square root of 1, which we know is 1. And so I have -5 plus 1 over 2, and -5 minus 1 over 2, which is going to give me -2 and -3, right? So quadratic formula always works. Factoring works if it is factorable, right? And so those are the 2 methods that you would use on the quiz. You would either factor or you would use quadratic formula to give me those zeros.